Hello everyone, in this video I'll be explaining the sixth program of data structure laboratory, that is to design, develop and implement a menu driven program in C for the following operations on circular queue of characters. The circular queue also implemented using array. So array implementation of a queue with maximum size max. Insert an element onto circular queue. Second, delete an element from circular queue. Third, demonstrate overflow and underflow situations on circular queue and display the status of circular queue. And finally, we have to incorporate exit function so that we can come out from these menu operations. Support the program with appropriate functions for each of the above operations. Let us understand what is circular queue first. Circular queue is an abstract data type that contains a collection of data which allows the addition of data at the end of the queue and removal of the data at the beginning of the queue. So it is like a queue only, where that is the insertion of the operations will be done from the end of the queue and the removal of the operation will be done from the front of the queue. And circular queues have a fixed size. That's why here while declaring an array for queue, I'm declaring also the maximum size. Circular queue follows FIFO's principle, first in first out principle, that is first inserted will be the last one to first inserted will be the first one to go out, not the last one. First inserted will be the first one to be removed from the queue. Queue items are added at the rear end and the items are deleted at the front end of the circular queue. But the shape what we are conceptually building or implementation wise, it follows a circular manner. That means I will explain with an example. Now suppose if I have three operations, that is let us consider the array of three elements. Okay, this is a circular queue for me. Now what I will do is, when I insert the first element initially, this circular queue, like a queue, is going to make use of two variables. One is front and another one is rear. So whenever you are inserting an element, whenever we are inserting an element, it will be done through the rear pointer, rear variable. So that's why I will increment rear and I will insert the first element. Let's suppose if I want to insert 10, then I will insert, so rear will become now 0. Now if I want to insert one more element, rear will become 1. So anymore rear will not be 0, rear gets incremented and then you're inserting the value. Suppose this array name is CQ of array R, CQ of R will be their item, CQ of R will be the item you are going to enter. So 20. Next I will insert 30 by incrementing rear first, then. So you can see that I have inserted element till the maximum size. Now if I try to insert more, it should tell that it is overflow because all three positions are occupied. This concept applies for the queue also. Now if I want to delete the element, I have to do from the front end. That means I have to increase front should point to 0 and then I'm going to delete this element. Now delete element is I have deleted 10. Next if I want to insert one more element, then I have to increment front and then delete this next element. This is what the normal queue does. Now what's the difference between circular queue? You can see here, in case of a normal queue, suppose if we cannot use the space of the array, because this we are not going to since these elements are deleted and we cannot use these positions again. For that, circular queue came into existence. That means we are trying to even make use of these positions again back. That is by even incrementing the R. That means R we are trying to use, because R is right now at this position, R will make point to 0th for the next element. Then if I want to insert R in one more element, then I will again increment the element. That means I am trying the R to go in a R as well as F if I want to delete in a circular fashion. So that is why the name circular queue. So now suppose if I want to delete now suppose if I want to insert, then what I will do, earlier there were these locations are empty right now. F is pointing to this location. So anymore if I want to insert, F should point to this location. Okay. So now if I want to insert an element, then what? Then R should point back to from 2 to 0th location, because the location will never get changed. Okay, location will never get changed. R is right now at this location. Now if I want to delete, if I want to insert, then R should come back to this position and you have to make use of this location. This is still a CQ. I have to make use of, I have to insert item to CQ of R. Okay. How do I make after 2? How do I make it to 0? That's why I am using the modulo counter operation. Like R will be equal to, every time I will increment, R will be equal to R plus 1 percentage maximum size. So that means when it reaches to 2 plus 1 percentage maximum size is 3 in this case, so this will be 0. Next again if I want to insert, then that is, let's say, suppose if I've inserted element into this location. Now next if I want to insert, then I should increment R again from 0. R will be equal to 0 plus 1 percentage 3 will be equal to 1. R becomes 1 and then I will insert 20. Okay, so this is what I am going to do. Finally R is at this position right now. Now you can see one thing, the first element is not anymore a 10, it is 30. It is 30 because front is pointing to this location. Front, so first element will be 30 this time, next 10, next 20, because F also goes in a circular fashion. So that circular thing we have shown like this. Here there are 7 elements, initially 10, 20, 30, 40, 50. So rear is pointing. Now if I want to insert, rear will come to this position. So 60, then 70 and then 80. Suppose if I want to delete delete an element, it starts deleting from the front. So finally front will come here. Suppose if I want to insert an element, right now rear is at this position, then I will you make use of rear equal to rear plus 1 percentage max. So the rear will go to this position and I will insert one more element. Okay, let's suppose that the element again I'm going to insert is 10. So rear, so your first element anymore will be 20, then the second element 30, fourth element third element is 40, fifth element, sixth element, seventh element, eighth, then last element is this, which is at the location 0. Okay, this is what is a circular queue. Now let's see the program. Hash define size 3 because I have defined the maximum size here 3, and then I will declare a circular queue using a array. It is an array implementation. So circular queue of size, front and rear initially pointing at the -1. Now as usual, in case of insert you are supposed to check for an overflow condition, and in case of a delete you are supposed to check for a underflow condition. How do we check for a overflow condition? Overflow in this case it becomes it becomes in a 2 case, suppose 0, 1 and 2. So front is here, okay, rear will be here. So now this time it is 1, 10, 20 and 30. So this is the first case. In the first case, what happens? The front is equal to rear plus 1. Front is equal to rear plus 1. Then you can say that it is overflow. Front is equal to rear plus 1. Okay, in that case also you can say that uh, it is overflow. I will tell, and the next I will tell front equal to 0 and rear is equal to size minus 1. You can see this is front is now 0, front is now 0 and rear equal to size minus 1. Size minus 1 is 2. In that case also front equal to rear and rear equal to size minus 1. In that case it is overflow, or front equal to rear plus 1. Let me explain about this condition now. Front equal to rear plus 1. For example, suppose the front is right now at this position. Front is right now in this position. That means this I got after deleting an element 10. And then after that I have increased I have inserted an element, increase the elements in the queue. Let's see what is going to happen. Now front is here, rear I'm going to enter is 15. That is, I will insert one more element, so rear will come at this position. You can see here rear is this time it is 0 and front is rear element, but the first element is at the 20 because first element is always pointed by a front. Second element is 30 and the last element is 50. So you can observe here the difference between front and rear, it is in plus 1. So front is equal to rear plus 1. In that case also we can say that the items are that means items that is all the elements are inserted into all the positions of the circular queue are full or occupied. So that's why it is overflow. Okay, it is overflow. Next, let us otherwise, if it is not overflow, then you have to read the element to be inserted. It may be 20, it may be 30. I will be keep on reading the element. For for each element you have to call a insert function. So if initially if the before inserting, if the f variable is still -1, you make it 0. After that increment r, because the first time if it is -1, when you are inserting the element for the first time, make f to 0, and after that increment r the line is like this: r equal to r plus 1 percentage size, and then insert the element. Okay, this is about the insert function. Similarly, let us try the delete function. So when it gets delete, then it is underflow. When the front value f value is -1, print f underflow. Otherwise what you have to do, you have to store the front element. Suppose for example 10, 20 and then 30. Okay, front equal to -1 means it is underflow. So front is pointing to this position, the r is pointing to this position. The location is 0, 1 and 2. Okay, front is pointing to 10, this is 20 and this element is 30. Now first I will to delete the element. You know that deletion will be done at the front end. So element will be equal to CQ of f. What is CQ of f? This is a circular queue array. So circular queue of f. F is 10. So element what you are going to delete is 10. Then you have to update f. F should point to this location after deleting this. Okay, so that is why f equal to f plus 1 percentage size, and you display the deleted element. Suppose in case of f equal to r, that means I will explain this part when this is going to, when I'm going to update f equal to minus and r equal to minus 1. For example, you have deleted all the elements. Let's imagine now the front you have deleted, front is pointing at, front is pointing at this location, that is the last location in the sense last element. Front is also pointing here, rear is also pointing here. And after deleting this element, again you should update, or again you should uh, assign the front and rear values -1, so that you can indicate that the stack is, sorry, circular queue is empty. Okay, after deleting this, f should not point to this location or any other location in where it should point. It should again point to, or it should have the value of -1. What do you mean by f equal to -1, r equal to -1? Means circular queue is empty. That is what we are doing here. That is only when you have a last element. Only when you have a last element. Next, the display. Now, as usual, if it is front equal to -1, that means it's an empty queue. There is nothing to display. Okay, and now I am going to display the elements from, if this is front, if this is rear, you have to display the elements from front to till rear. So front should get the initially, I should get the value of 0, that can be obtained from front. Then I should be get incremented, that means it can be done with I equal to I plus 1 percentage size. This also should go in a circular manner. That's why I equal to I plus 1 percentage size until I not equal to r. Okay, moment I becomes r, okay, it will print here, that is last element gets printed here till last but one element. Till last but one element I am printing from display, and the last element is for the last element it will come out of the for loop and it prints here. So this will print last element. So that means within the for loop only this line gets executed. Printf, first printf gets in. Once the for loop terminates, or the loop gets break, then this line gets printed. That means it's going to print the last element. Okay, this is about the display function. Then after that, main. What is main? Main is mainly holds all your main operation, and it reads the choices from the users. And that's why I'm printing the menu, here. Then I will enter the option scanf percentage d ampersand choice. So it will read the choice. If the case is 1, then I will insert. I will call the insert function. If the case is 2, I will call the delete function. If case is 3, that means if the choice is 3, I will call the program or main function will call the display function, and case is 4, it will call the exit function. So finally, default function, default case is saying that it is a invalid option. So other than 1 2 3 4, if you have printed anything else, it will go to the default case and print invalid option. So this is about the program. Now next we'll see the output. So let us run the program. So GCC, I've already stored the program. So I have named the program as circular queue cirq.c, and I will store the output. If the compilation is successful, then the output gets stored in the circular queue, and then uh, I will start showing the output. That's why start circular queue, because output gets stored in the circular queue. So this will open. Next, I will increase the size of the window. So here enter, it will display the main, and all these options are from the main, that is insert, delete, display and array, and it will ask to enter the option 1 2 3 or 4. So first I want to create I want to insert some elements into the circular queue. That's why option I'm going to give as 1. Insert. It will ask for the element I'm going to insert is 20. This is the first element I'm going to insert. So I will show you now the locations of f and r, because f is 0 and r is 0 right now. Only one element, that is 23. I will make queue full. That's why I will enter one. I will ask for the one more insert operation. So at this time I will insert 34. One more time I will call insert function. This time I'll enter 67. We'll display the circular queue. You can see here front is located at 0th location, and rear is located at the 2nd location. Now I will delete one element. So that is 23, because always when you're deleting you're deleting from the front end. It is first in first out. Insertion also will be done from the uh, rear end, and deletion will be done from the front end. Okay, next I'm going to delete the next element. So what's the element? 34. So you can see here now the circular queue contain only one element, that is 67. Front and rear is pointing at 2. So front is now. If I'll try to insert one more element, that is 45, and I will try to display function is option is 3. So you can see here just now I inserted 45, that is here. Front is at location, that is 67 is at location 2, whereas 45 is at location 0. This is what shows the circular behavior of the this is how you can show the circular behavior of the circular queue in the demonstration. So now I will try to show the empty circular queue. That's why I'll perform 2 more times delete operation. So deleted element is 6, because deleting always done from the front end. One more time and one more time. This is what underflow, and finally I will press 4, and 4 will make you exit from the output. So you have again come back to the that original prompt. So this is what the explanation and demonstration of the circular queue program.